In this video, we are going to talk about exponential applications. We're going to look at two different kinds of compound interest formulas. So this first one is kind of like the regular compound interest formula. This is when things are compounded, let's say monthly, weekly, daily, maybe even yearly, things like that. So depending on what textbook is used, the letters that are used in this formula might be different sometimes, but the actual formula itself is always the same. So I want to talk about what each of these variables mean, each of these letters. A is what we call the amount, and usually that is the current or future amount. P is what is known as the principal, so that is the initial amount. R is the interest rate. Now, we'll talk about this a lot in all these examples, but we have to turn our interest rates into a decimal. Remember, we can never work with percents in percent form. N is the number of times interest is compounded in 1 year. And then T is time in years. So that's what all of those different variables stand for. So let's look at an example of how to set this up, and then I also want to talk to you about how to put this in your calculator correctly if you're using a graphing calculator. So we have an initial deposit of $1,000, so that's the principal. P is 1,000. It's earning 9% interest. So remember, we have to change that 9% into a decimal. So what we can do is divide it by 100, and that would give us 0.09. So that's 9% as a decimal. And then it is compounded monthly, which means in 1 year, it would be compounded 12 times. Then we want to know how much will be in the account in 4 years. So T is equal to 4. So when we set this up, we'll have A is equal to 1,000 times 1 plus 0.09 divided by 12 to the 12 times 4 power. So let's talk about how you have to put this into your graphing calculator. So as you can see on my calculator screen here, that parentheses are really important. So I have to put parentheses here around this fraction so that I make my calculator follow the order of operations. And I also have to put parentheses here to represent this exponent. So when we go ahead and we calculate this, we end up with 1,431.405333. Now, we're talking about money here. So this answer doesn't make sense. We want to round to the second decimal place. So this would be $1,431.41. So that's how much they could expect with 9% interest after 4 years, compounded monthly if they only invested $1,000 to start. Okay, so the next one is similar. We have a credit card company charging 21% interest, so that's R. Remember, we have to divide it by 100 to turn it into a decimal. It's compounded monthly again, so N is also 12 this time. You are initially charging $1,500, so that is P, the initial amount, $1,500. And then time, it says we're going to pay it 1 year later, so t is just 1. So let's set up the formula. We have a is equal to 1,500 times 1 plus 0.21 divided by 12 to the 12 times 1 power. Now, when I go ahead and put this in my calculator in a minute, I can just multiply this. 12 times 1 is just 12. So that's what I'm going to enter in my calculator. So here's that calculator screen again, showing you exactly how you have to put the parentheses around that division right here. So parentheses around here. And then we don't need the parentheses on the exponent because remember we said that was 12. So if you go ahead and you compute that, you end up with a is equal to, now we're going to round this to 2 decimal places again, $1,847.16. So at 21% interest compounded monthly, after 1 year, you'd end up paying almost $350 more than you initially charged. So this next formula is also a compound interest formula, but this is when we have continuous compounding. So the only time we use this formula is when we are told that interest is compounded continuously. So just like before, A stands for the amount in the account. P is the principal or the initial amount. R is also the rate as a decimal. So just like before, we can't work with percents as percents. And T is time in years. Now, it's important to note that both the R and the T are in the exponent spot. Okay, so we have an initial investment of $2,000, so that is P. It is earning 8% interest, so as a decimal, that's 0.08. Now it's compounded continuously, which means we're going to use that formula that we just talked about. And then the investment, we want to know how much it will be worth in 15 years, so that is T. Okay, so let's plug everything in. We have A is equal to 2,000 times E to the 0.08 times 15 power. So again, let's look at how to put that in your calculator. Remember, E is just a number and you have an E button on your calculator. On the far left, you'll have to press second and then the LN button to make it come up. So in the graphing calculator, it actually puts this first parenthesis in for you, and then I just did 0.8 times 15, and then just remember to close it with a second parenthesis. So just like before, we are going to round this to the nearest hundredth because we're talking about money. So this would be $6,640.23. So at 8% interest compounded continuously, after 15 years, you'd have almost $4,640 more than you started with. Okay, so our final example is going to be just slightly different. An account now contains $11,180. So that is A, $11,180. It's been accumulating interest at a 7% rate, so R is equal to 0.07. It says it's compounded continuously, which means we're using that A equals P times E to the RT formula again. And then time is 7 years. And this time it says find the initial amount, so we're going to go ahead and find P. So let's plug in what we know. 11,180 is equal to P times E to the 0.07 times 7 power. Now remember that e is just a number. So all of this we could put in our calculator and compute. And it's just being multiplied by p. So remember, we can undo multiplication using division. So if I divide by e to the 0.07 times 7th power, I will just be left with p on the right-hand side. And then I can just compute this in my calculator. So these will cancel, you can see, and I'm just left with p. So I'll show you how you would enter that in your calculator. So if I want to put this into my calculator all in one step, what's important is that I've put this entire denominator inside these parentheses. So after I do my division sign, which represents this fraction bar, all of this denominator has to go in parentheses. So if we compute that correctly, again rounding to the nearest hundredth, we will get $6,849.16. So that's how much we started with, and it should be less than what the account has now because it's been earning interest for 7 years.